This last video for 4.2, we're just going to go over some of the basic theory on zeros of polynomial functions, and then we're going to learn how to factor and sketch polynomials. So the first thing is, I've already kind of mentioned this, but I'm just putting it in concrete form, is that if you have a polynomial of degree n, then you're expecting a maximum number of zeros of n. So if you have a 6-degree equation, you can have up to 6 x-intercepts. So 1, 2, 3, 4, 5, 6. Okay? You do not need to know this for any useful reason. Well, maybe useful. But if you have up to 6 x-intercepts, you'll get up to a maximum number of 1, 2, 3, 4, 5 turning points. So turning points is where you go from like a positive slope to a negative slope, right? And so if you have 6 as your degree, you'd have 5 as your maximum number of turning points, which is 1 less than your degree. Okay, so this is just a random question in your textbook, just making sure that you got that theory. So for this one, again, you're using your leading term. So this one has a highest exponent of 6, or highest degree of 6. So this would have 6 max real zeros, and there'd be 5 turning points. What about the next one? The next one has a degree of 4, so you'd have up to 4 x-intercepts, and you'd have up to 3 turning points. And now that we've done that whole multiplicity thing, it's a maximum because some of them might have multiple multiplicities, which means that you'd only get like 3 x-intercepts, but you could have multiplicities that make them count for more, like they'd be squared or cubed or something along those lines. All right, now what we're going to do is just get back to sketching. So how are we going to sketch? Well, we're going to sketch these polynomials that aren't in factored form. So our job is going to be factoring them, and then we're going to sketch them either using multiplicities or the interval method, which nobody ever does. So let's start off by factoring. Now, at this point in your learning, you only know the basic factoring. So when I look at this, I see a greatest common factor of x cubed, and I'm going to take the sign of the first term. So I'm going to say that this is negative x cubed times x squared minus 1. So if I divide both of those terms by negative x cubed, I'm left with x squared minus 1, which I could factor further to x minus 1, x plus 1. Then I can use my rules for sketching. So step number 1, I'm going to use my leading term test to determine my end behavior. This is an odd, negative graph, which means that it is going to start in quadrant 2 and end in quadrant 4. I'm picturing that linear function flipped across the y-axis, so it's going to go from 2 to 4. Then I'm going to figure out what my zeros are and what their multiplicities are. So I have an x-intercept at 0, 1, and negative 1, so I'm going to write them in numerical order. So I'm going to go negative 1, 0, and 1. Then I'm going to state their multiplicities. So the 0 of negative 1 has a multiplicity of 1, the 0 at 0 has a multiplicity of 3, and the 0 at 1 has a multiplicity of 1. So I'm going to cross and flatten, and I'm going to cross. All right, let's plot my x-intercepts. Oh, it's so squished. Surely I could have made it nicer. Okay, well, here we go. Let's squish it. We should have had a different scale. Okay, so I'm going to start in quadrant 2. My graph's going to magically end in quadrant 4 if I cross, flatten, touch, or cross, flatten, cross. So I'm going to go cross, come back up and flatten, come down and cross. Aw, it's so squishy. Okay, it's a sketch. I mean, it's not awesome. And again, we could check this with Desmos. Actually, let's do it. I'm always so nervous of making mistakes on videos that I really like to check on Desmos, just partially for that reason. So I started in quadrant 2, I ended in quadrant 4, and then let's just zoom in on these x-intercepts. Oh, they're so sad looking. So I crossed through at negative 1, so my scale is 0.5 on this one. I flattened out at 0, and then I passed through at 1. So we did an awesome job. Go us. Okay, hopefully you could see that. I noticed that when I was reviewing a video, half the thing was cut off. So pass, touch, or pass, flatten, pass, or cross, flatten, cross, whatever you want to call it. All right, we did great. So what about the next one? So this one we had a greatest common factor, and then we were left with a difference of squares. What about this one? So again, we always check for a greatest common factor, which this does not have. And then we notice that there's 1, 2, 3, 4 terms. So I'm going to assume that this factors by grouping. Out of this first group, we're going to take out an x squared. If we take out an x squared, we're left with x minus 2. For this one, I'm going to take out a negative 4, and I'm left with x minus 2. So I'm going to greatest common factor out that common bracket of x minus 2. I'm going to be left with x squared minus 4, which is a difference of squares. And we'll factor to x minus 2, x plus 2. Sometimes I think I write too fast. There you go. Then you'll notice that this x-intercept is written twice, so we'll just write it with a multiplicity of 2, or we'll write it as squared. And then we'll do all the things. So this one is an odd degree with a positive leading coefficient, which means I'm going to start in quadrant 3 and end in quadrant 1. I have an x-intercept at negative 2, and I have an x-intercept at 2. Negative 2 has a multiplicity of 1. And I've kind of dropped that step, right? So this one came from x plus 2 equals 0, right? This one came from x minus 2 equals 0. And this one has a multiplicity of 2. So the graph is going to cross and touch. So now let's plot them. So an x-intercept of negative 2 and x-intercept of 2. I'm going to get my graph to start in quadrant 3. It's going to magically end in quadrant 1. And I'm going to cross through this x-intercept, and then I'm going to touch at this x-intercept. And I've got my graph. Awesome. Have fun with your homework.